Hello everyone, I'm Sanmathi. I'm an intern at Emertxe Information Technology. I'm doing this internship of embedded systems, and during this internship I have built a project on micro oven simulation. So let's get started. The topics which I have learned during this internship are Introduction to C programming language, conditionals, loops and operators, arrays and pointers, functions and strings, introduction to embedded systems and microcontrollers, MPLAB, XIDEE, XCB, compiler, PiximLab, introduction to PiximLab and introduction to various peripherals of PIC16F877A. The contents that are included in this project are what is microwave oven, requirements for building this project, microprocessor and microcontroller, Pixim Lab, CLCD, matrix keypad, ISR, timer, project implementation demo. So requirements MPLAB IDE, XC8 compiler, PiximLab, PIC16F877A, 16x4 CLCD, tactile switch, MKP, timer 2. So let's know about microwave oven. What is microwave oven? A microwave oven is relatively small box like oven that raises the temperature of food by subjecting it to a higher frequency electromagnetic field. A magnetron takes electricity from the power outlet and converts it into a high powered during cooking. Generally, microwave oven consists of four modes. First mode is micro mode, grill mode, convection mode and start mode. Coming to the first mode, which is micro mode. This mode is used to cook food in a traditional way. Second mode is grill mode. This mode is used to cook meat and bread. It works as the micro mode, but the purpose is to cook meat and bread. Third mode is convection mode. In this mode, user can set the oven to preheat for particular temperature and it takes 3 minutes to preheat the oven. Let's know the difference between microcontroller and microprocessor. Microcontroller is a component that performs the instructions and tasks involved in computer processing, while microprocessor a compact integrated circuit designed for a specific operation in an embedded system. Microcontroller is used for applications that require intensive processing, while the microprocessor is used in an application to perform specific tasks. Microcontroller consumes more power, while the microprocessor consumes less power. Microcontroller has a high clock speed. Microprocessor has a low clock speed. MKP, which is nothing but matrix keypad. What is MKP and what is it used for? This is used when more number of user inputs are required and still want to save some controller lines. These keypads are most commonly used in telephones, calculators and digital lockers. CLCD, Character Liquid Crystal Display. We can see the image of CLCD in the screen. In PiximLab, there are two types of display. First is 16x2 display. Second, 16x4 display. It displays the ASCII character and some special characters. Two types of communication modes are 4-bit mode and 8-bit mode. This is the PiximLab architecture. And pin diagram of PIC16F877A, which is nothing but a popular microcontroller from Microchip's PIC family. It is known for its versatility in embedded applications. Generally, this contains of 40 pins in which 5 ports are bidirectional. This is the PiximLab architecture. Here in this we can see the buzzer, digital keypad, matrix keypad, CLCD, temperature sensors and RTC EEPROM. PiximLab. This is how the Pixim simulator board looks like. PiximLab is a popular open source circuit simulator primarily used for simulating and testing microcontroller based circuits. While it's a versatile tool for electronic simulation, it may not be the best choice for simulating a microwave oven, primarily because microwave ovens involve complex electromagnetic interactions that go beyond the capabilities of a microcontroller based simulator like PiximLab. PiximLab is primarily designed for simulating microcontroller based circuits and does not have built in capabilities to simulate microwave ovens or their specific cooking modes like microwave, grill, convection, etc. Microwave ovens involve complex electromagnetic interactions, heating processes, and safety mechanisms that go beyond the capabilities of a microcontroller simulator. Interrupts. In an interrupt, it is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MCU to stop the processing. Then the MPU or MCU acknowledges the request and attends to the request. Goes back to the processing where it was got interrupted, which is nothing but disturbed. ISR Interrupt Service Routine. An ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. When an interrupt occurs, the MPU completes the instruction being executed. Then it disables Global Interrupt Enable, places the address from the program counter on the stack. Timers. Timers is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with a system clock or an external clock. Timer or counter is a software designed to count the time intervals between the events. It has many applications such as measuring time and generating delays, etc. Resolution, which is also called register width, 8 or 16 bit, etc. Here I have uploaded some of the images of the output of this project. First image is start mode. Then coming to the second image, here we can observe the four modes of this microwave oven. This is the micro mode and second grill mode. Convection mode. Convection mode is nothing but which is similar to that of micro mode. Here we can set the temperature. Then comes the start mode and the time up mode. So now I have completed this presentation. Now let's move on to the code presentation and let us observe the output of this simulation. Now let us discuss the code. This code is written in MPLAB XIDE. At the starting, I have included all the library files. Then we have initialized all the variables and here the main program starts. We are using the while loop. Here I have included all the four modes like start mode, convection mode, grill mode and stop mode, and at the end we are declaring all the functions. In the main file I have mentioned all the prototypes. Now let us start to build this project in PiximLab simulator. Now it will take some time to build the project. In PixSim simulator, we will check the output. Now let us load the hex file first. Here we can see all the modes has been displayed. If we click on 1 and 5, it pauses. If we click on 6, it stops. Again, it will show us the menu. Preheating timer, it prevent oven from damaging. In this PixSim lab, if the time is up, we hear a buzzer sound. If the buzzer is at right, it does not work, so it must always be at the left. Micro mode, we can select the timing. In the grill mode also, we can set the timing as per our requirement. In convection mode, we need to set the temperature and preheating time over here. Then the last mode is start mode. It is an automatic start mode which has 30-second default timer, and once the timer is done, the buzzer will on and will get the symbol of time up. Now let us discuss about the grill mode, which is similar to the micro mode and the convection mode. We need to set the temperature first. Here you can observe it is starting to preheating. This is a 3-minute preheating timer we have mentioned in our project so that it will prevent from damaging of the oven. In this preheating oven, it will start to preheat and we will be able to cook our food properly. So in this PixSim lab, if we switch down the first key of LCD towards downward, then the display of CLCD will go away. If we click on the upward, then it will be visible. So always make sure that it should be corrected towards up. Now it has been corrected towards the upward. Similar to the buzzer, as soon as the timer is up, we will start to hear the buzzer sound. It is always decided by the user. If the user sets the time of up to 30 seconds, then it will last up to 30 seconds. If he has mentioned till some more, if he takes some more time, then it will be managed like that itself. If the time is up, which is given by the user, the buzzer will start to ring. It should be always towards the left. If the buzzer is towards the right, it will not ring. Now it's preheating. Similar to the LCD, it is 16:4. So if it's 16:4, then it will display all the 4 lights. If it's 16:2, it will display only the 2 lights. Timing is also visible to us in this CLCD screen. And here we are using PIC16F877A microcontroller. This project is built during 1 month of internship. Still we have to wait for some time because the auto timers will shut down. As soon as the auto timer will shut down, the screen will start to display the timing. Here I have chosen MPLAB XIDE to write the code and PixSim simulator to simulate our code and observe the output. Compiler is used to compile the code. Still we have to wait for some time so that the preheating will be completed. The timer is increased by 30 seconds. We can give the pause to it as per our requirement, or else we can move. Still we have to wait for another 30 more seconds. Here in this we can observe the cooler, the heater and the buzzer. Here we can observe all the 8 ports. Now if we press 6, it will stop. And at last the grill mode, in the grill mode timing of 2 seconds, it starts. Now if we click on the 4, the timer is again increased by 36 seconds. If I click on RB3 of tactile switch on PixSim simulator, it will indicate and door will open. Here we can observe the fan is starting to move. And now here we can see the menu bar again, start, pause and stop. If I press 4, it will start or it will resume. If I press the 5th, it will start again. The screen has been cleared. Now I would like to thank, now here you will see the time up. I would like to thank the Emertxe technology for giving an opportunity for this internship. I hope you all like this. Thank you. Now I am going to end my presentation. Thank you.